Any more questions, let me know. The rational root theorem is just another way to find solutions to a polynomial. So if you're given this polynomial, you're going to have four solutions. Well, we're talking about, like, when people came up with this was like the 1600s. So when they figured out this method, it was exciting because before, if you're looking here, there's no GCF, there's no factoring with the difference of two squares or difference of two cubes. So when Rene Descartes figured out a way of, rather than graphing this whole thing, which is insane, and then figuring out your solutions, or trying 1, trying 2, trying 3, trying 4, trying 5, trying 6, trying 7, rather than doing all that, he honed his search in by using the rational root theorem. So this was exciting back then. I know it's like not that exciting to you. But for these mathematicians where this was their whole lives, this was super exciting. So Rene Descartes said, okay, instead of trying to figure out all the numbers that would work, let's hone our search in. It's kind of like when you use Google. You type in a vague search. You would type in Algebra 2 help. Well, that's pretty vague. You're going to have a lot of stuff come up. So you hone it some more. Polynomials. Then you hone it some more. Rational root theorem. Okay, so you've honed your search in and you're telling yourself, all right, what's something I could try that would be easier than just plugging in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 or negatives. You're going to have factors of 1200 and put them over factors of 1. The problem with the rational root theorem here is that that's a lot of factors. And it isn't the 1600s. It's 2020. Crazy. So, like I said, Rene Descartes didn't have a graphing calculator, but we do. So, if you go to y equals and graph your function, make sure this is right. You can kind of cheat. You're going to graph, and this is supposedly an equation of a roller coaster, the height of a roller coaster. So you know what I mean? It's going to go up, it's going to go down. And if you look here, you cross the x-axis at not 1, but 2 and 4. So you know at 2 seconds and 4 seconds, okay, that's your time, your height's going to be 0 or ground level. So after 2 seconds and 4 seconds, supposedly. If you keep going down, okay, it looks like there's more over here. It looks like there's nothing here. Well, yeah, that makes sense because time isn't negative. So we don't need our x-min to be negative. We can just put it as 0, and maybe our x-max is at 20. So at 1, 2, 4, and, oh, looks like another pretty one. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So let's just make sure that these are all the answers. So you could just have not cheated, but used a resource without doing any work. And at 2 seconds, 4 seconds, and 15 seconds, you have it. So let's see if they work. You can actually physically plug in the numbers, or let's kill two birds with one stone and use synthetic division. So if 2 isn't actually a solution, 1 t to the 4th, negative 31, 308, negative 1100, and 1200. You would drop 1. 2 times 1 is 2, and that'd be negative 29. Then 2 times negative 29, which is negative 58, plus 308, would give you 250. 250 times 2 is 500. So 500 plus a negative 1100, which would be negative 600, and double that would give you 0. So yeah, 2 seconds works. So it will hit the ground at 2 seconds. Okay, so you're imagining a roller coaster. 2 seconds, 4 seconds, 10 seconds. Let's make sure they're right. So now we're down to this polynomial, which is remainder of 0, constant, x squared, and x cubed. So we're going to use this again now, and you can take any one of these. You just don't use the same one again. So we could use 4, 10, or 15. I'm just going to use 4, and we'll put it here. 1, negative 29, 250, negative 600. You drop the 1 times 4, negative 25, That would give you negative 100. That would give you 150. That would give you 600. Yeah, so 4 worked. So 2 seconds, 4 seconds. This one just happened to be really pretty. You don't have fractions or irrational numbers. And then you just keep chipping away and putting in 10 and putting in 15, and you're going to get 0. We can try it. So this is going to be a remainder, your constant, your x, and your x squared. So we're going to use now 10 and see if that works. If we didn't have a remainder of 0, it wouldn't work, and our answer is wrong. So put 1, negative 25, 150. Drop the 1, you get 10, negative 15, negative 150. Yep, it worked. And we're left with x minus 15. Well, obviously 15 works. So at 2 seconds, 4 seconds, 10 seconds, and 15 seconds is when your roller coaster is going to hit ground level. Okay, so we really didn't have to use a rational root theorem. It would have been an insane amount of time using the rational root theorem. So that's why I just say use your graphing calculator. Your professor, I hope, wouldn't expect you to know how to do that by hand. When we do it at Barron, you don't have numbers quite this big, but you do have to do it all by hand, and you can't use a graphing calculator. So if you're going to a math-related field, be prepared for that. All right, now we're going to go over these 2 questions from page 355. I've requested, or someone's requested 24 and 36. Okay, and for this one, let's go back to the directions in the book. They wanted to know, given a polynomial and one of its factors, find the remaining factors. So they want this polynomial broken up into 4 linear factors. And when we say linear factors, it's when we have x to the first. So this is going to be the same thing as x minus 2 times something times something. They gave you 2 of them already. That's nice. So I would just start chipping away using synthetic division. So 2, 4, negative 16, 7, 36. So dividing chips away or breaks down your polynomial. Okay. So now we're down to a reduced polynomial. It's not x to the 4th anymore. It's going to be x cubed. So we have now, I didn't even have to write all that out, but we use 2 again because we have 2 of these. So you're going to have 4, negative 8, negative 9, 18. You're going to drop 4. Okay. Now you kind of have to do this on your own. We have a remainder, we have a constant, we have an x, and we have an x squared. So what's left is 4x squared minus 9. Well, we can break that down on our own. We know that's going to be the difference of 2 perfect squares, 2x plus 3, 2x minus 3. So these are all your factors. So if you were to go and FOIL and distribute back, you would get your original polynomial. So you wouldn't have naturally been able to do this on your own. You could have graphed in your graphing calculator and saw that it crossed at 2 and been able to do this. But if you didn't have a graphing calculator or this, you'd have to use a rational root theorem. So this is all linear factors. Isn't that true?